Hey guys, Bradley Washer here, and I just wanted to talk a little bit about this sci-fi level that comes with Unreal, and imagining if this was your level and you needed to get it to be a little bit more performant in terms of rendering and optimizations. So when we want to come through here, I'm primarily going to be talking about lighting and some post-processing effects. But let's take a hypothetical that this was the level in your game. Maybe you're working with someone else or you're trying to figure it out for yourself. How could we make this more performant? What could be some cheap and easy things that wouldn't really take away our quality, but give us back some either GPU time in case that's what was kind of keeping us limited? So the first thing I noticed when I opened this scene up was I took a check at the lights. We can think of rendering in a couple different ways. The first is kind of a high level, which we won't go into too much in this video, which is just your renderer. Are you in forward, forward plus, are you in deferred? And really what that means, if you don't know what those are, is the way in which an image, that thing we see on the screen, gets calculated. They have their pluses and minuses. By default, Unreal is in deferred, and so we'll have that consideration when working on this project. The next thing I'm going to make and state is, let's hypothetically say that we don't need the lights to change in this environment. The lighting that you see now is what you will get. We won't go to black or dark or anything like that. In general, it would stay the same. So what I'm going to look for are a couple things. The first thing I usually do when I come into a level is just look at the mobility of the lights. And so the mobility of the light does cost, the cost does vary based on its mobility. And you might be asking, well, what is that? There's really only three: static, stationary, movable. The long, short, static lights don't really directly affect movable objects. That information they provide is stored into baked information in the form of indirect lighting cache or volumetric light maps. And so they're the cheapest. That's the long short you need to know. Stationary lights are the same as a static light. They bake their information into static meshes. So anything marked as static will get static lighting. And what they also do is they influence movable objects by actually causing a little shadow, how do you want to define it? A shadow casting camera, in a sense, under the hood to make sure that it actually casts a proper little shadow from this light source, if it is shadow casting, which you can see over here, this light is. And the other thing it does in stationary mode is generate shadow masks. And so what is a shadow mask? The long short, it's a mask that kind of lays and hits where this light can influence. So that way later, if we need to turn the intensity down to 0, let's say we want to turn this off, its influence can be turned off, and when we turn it back up, it knows what surfaces it can hit. The downsides and upsides of that is basically we have to pay that cost for the shadow caster, and then also we have to pay memory cost for that texture, that mask that this light is saving out. And so that's kind of the long short on stationary lights. And then movable lights is we're going to pay per pixel cost for anything that this light's touching. It's just rendering everything though. So this object, this vacuum here, this little Hoover Dyson thingy, if it's inside this light, it's not creating a new custom shadow caster for it. If I make a second one, I don't pay an extra cost. If I make a third one, it's still the same cost. The difference being, if this was stationary, each one of these would be getting its own special kind of shadow casting camera, and that can be performant. So depending on how many characters you have in your game or movable objects, it sounds kind of crazy, but sometimes a movable light is cheaper. It just depends on the effects in your environment you need to do as well. So back on task. This light was here. A couple things. This light feels like it's just an ambient fill, almost as if they weren't getting quite enough light into the environment. So we'll leave it for now. But I'll honestly set this light just to static. It doesn't seem like it's going to cast a strong shadow for any character moving through here. So you ask yourself, what are your dominant light sources? And I would suggest that some of these coming from the ceiling would be more likely to want to be a shadow caster. And I might even prefer for performance, take this spotlight and turn off shadow casting. Now, some things you might be noticing, we have to decide if the loss of the shadows on these is important or not, but because we're gonna be setting to static, it won't matter. So we can leave that on, these shadows will get baked, and we're gonna keep them, and we don't have to pay any real-time runtime cost. The next thing I would look at is some of these ceiling ones. I would keep most of these at stationary. The only caveat is how we had talked about that shadow mask being generated, which is kind of like, again, it's a mask of where the light is hitting. What Unreal is doing behind the hood is, let's say that we have these two lights and then this light here and then this light here. What you'll notice is that their influence radius, this kind of cone that's being created by each one, if they overlap and you have a mask, you can't have each mask be white. You need them to have their own individual color, so that way Unreal knows which light mask is for which light. So what it does under the hood is, if they're close, it packs them into an RGBA texture. And what that means is we're limited to, again, RGBA, which is 4 channels. We're limited to 4 stationary lights overlapping, which you can find out in terms of performance, which is not happening here. But if we were to take one of these stationary lights and dupe it a couple times, if you've ever noticed one of these red X's in your project, that's really bad, because it basically means that 4 lights are overlapping that are stationary. You won't have this problem if this was set to movable, and you won't have this problem if it's set to static. It has to do with the shadow mask and the way it gets packed. So hopefully that helps some people if they're running into that. You have to pay an additional entire call once you go over 4. So the way you want to avoid it is check for those red X's. And then the other thing you want to do is come into lit, this tab right here, come down to optimization views and the stationary light overlap. This view is showing you where stationary lights are overlapping. So some of these darker areas we can see is just one overlap. If we dupe this, you can see now this whole area has been overlapped, and red means we have too many. So if it gets more egregious, we're paying even more cost. These lights, if they turn to a red X, what really is happening is they're turning to a movable light. So now you have 2 pixel casting real-time lights for anything they hit. So the cost just went up crazy in terms of performance on these. So I don't recommend doing that. Once you're done with that, you come back to lit mode. So a couple more performances. Some of these wall lights, again, depending on the cast from the character, we don't need it. So I'm going to save some texture memory, set this to static, the same one next to it, set it to static. On all these corner ones, because again, I don't need to change the brightness in this scene. Let's just say it's going to be consistent. It's not going to be a problem. What I might do is, these main lights are covering a big enough area for my character to walk through and cast a shadow. So again, these ones I might even set to be static. Now, the reason why we might not want to do that is if we wanted a dynamic shadow more so on these doors. But because these other lights are so close behind, they're going to generate that shadow for us as well. And the same goes for this one. I'll set this light to static. Now, in terms of lights, we can definitely come through here, see what needs to be static, what doesn't. Again, like these ones sitting in the room, they're just kind of like a bounce fill. I don't think we need to set these to be stationary. Again, they don't really need to pay the cost. If the character were to walk into this influence volume, it would start automatically generating a shadow caster for him, and we're gonna have to pay that entire cost. And we don't want to do that. We want this to run as fast as we can. So some of these little fill lights for this static environment are gonna be fine. The next thing I would look at are these reflection probes. And reflection probes are really just capturing the room around them in terms of 6 images. It kind of captures them and it's like a camera with 6 lenses. Takes a snapshot from this specific spot, and then anything within this volume uses that image of the environment to help create reflections for really cheap, because true reflections are expensive. One thing we'll look at later is there are screen space reflections, these kind of nice one-to-one reflections, but as we get away, you'll actually notice that there's a distance when that doesn't become true anymore. You can see it kind of fading in and out there, and that's an optimization of the engine that we don't want to have to pay. So back to these reflection probes, as they overlap each other, we have to pay kind of the cost of figuring out the influence of each one that overlaps. So because these two are over each other and it makes up the pixels here that make the reflection up, the GPU has to decide how much of each one is in each one of these pixels. So if I add a third reflection probe, now it has to do more math. It says, okay, how much is this one contributing, this one, and this one? If I add another one, it has to know the average of these three. So there's more math. And the long short of the GPU is the less math, the better. So a good rule of thumb that is a way to start with your reflection probes is I like to take one, usually relatively general to the middle, and I'll scale it up to fit a significant portion of my area. It just so happens this is a pretty small space. If you had a really big level, I wouldn't suggest doing this, but in this case, making one big influence that kind of catches it all, and then I might run two smaller influences kind of like that at the end, and then I'll get rid of this and just have another one at the end here. Again, kind of small, and then maybe, yeah, one more back here. One thing I noticed about this reflection probe is it's actually really tiny, so some of the meshes aren't getting the full benefit of the cost of it being here. So if we increase its radius, it actually, you'll see some of the reflections start to change around. Like now that it's hitting this back wall, you'll see right here, we're getting these reflections. If we sized it back down to what it was, we don't get that as much. We're getting a different type of reflection. So we're getting screen space reflections. And so I might bump that up just a little bit to help kind of influence that room. So yeah, something like 320 is probably fine. So now that we've optimized down some of our reflection probes to make sure there's less averaging that has to happen for the reflections, we've set some of our lights that were stationary to static. So we've cleaned up some of it. You can notice there's still a ton, and feel free that you basically want to think if the light isn't going to turn off, change intensity or color, or need to actually cast a shadow for a playable character, this can totally be set to static and you will save a bunch of GPU time. The next thing I look at is the post-process stack. And so what do we need to do? So in most levels, you will find what is a post-process volume. So in the outliner, I like to go post. And you'll notice in this level, there's actually three. The first one, I did a little bit of investigation, and if you look at the enabled state, it's actually disabled. So this is kind of an artifact that was left behind. If this is something you want to do as like a last minute change to the whole thing, it looks like that's what they've done, is just made an unbound. And if I check, yeah. So what this has been set to is basically, you'll notice these other post-process volumes. If I click on number 1 or number 2, they have a size. There's this yellow kind of box. When I'm not clicked on it, it's purple. And you'll notice that whenever I go inside this box, you can see that it looks different in the level. And that's because this box, whenever we're in it, has a bunch of information on it, as you can see right here, that changes the pixels that are rendered out. So when we're not out, the pixel math is different. When we're in it, it uses all this to influence how the pixels look. And it does that by doing a bunch of different operations. Some of them are depth of field. So again, think of everything that happens in the post-process volume as doing math on pixels. Okay, so this whole image right here is made of pixels. And when we want to do depth of field, it's going to have to say, oh, this is at a certain distance and it's going to be blurry now. So do some math that looks more blurry, averaging the colors out and whatnot as we go. And so there's a cost to doing math. So anytime we can get away with not needing one of these operations, we're going to save time in terms of calculations. So let's do an example. If we have this first process volume, and you can see it takes up this main room, and when we're in it, we can see it's affecting our level. And let's say that we're still kind of slow. So I'll look through these image effects that are under the lens. And one thing you'll notice is like a couple things are on by default and you don't really realize. So vignette, if I put this back to its default, vignette adds this darkening effector on the outside of the image. It's to simulate how lenses work in real life. Sometimes they're kind of low quality and less light gets in around the edge. It also kind of focuses our eyes as humans. But if you notice in the tooltip, if you hover over it, if we set this all the way to 0, we don't have to pay the extra math cost on those pixels to turn them black. So again, think about the image. We had to pay a cost to add this darkening effect around the image. And it's not free. We have to pay for it. But if we set this to even like 0.09, you don't notice it, but we're paying that math calculation still, okay? So setting this to 0 will disable it, and we won't have to pay that additional cost. So if you're running kind of slow and there's some things you don't need that are on, we can come in here and disable them. Another one we could do, bloom. Let's say that we don't need bloom in our scene, turn it off completely. We just saved ourselves some more performance. Again, because to create bloom, you'll notice it has to look at every single one of these pixels and apply the math to make the bloom happen to every single one of them. And then it had to go and it had to figure out the math for vignette, and then it had to figure it out for exposure, and then for color grading. And so you can see how as these post-process effects stack up, we have to pay more and more and more. Now, there's a compromise between what your game needs. Let's say you have this very ethereal look, it needs to be very soft. Then leaving bloom on and having to pay the cost is probably a necessary evil. If we have a very realistic game and we don't need it, setting this to 0, especially on, let's say, like a more optimal build of your game, really doesn't take too much away. The player isn't going to really notice it. They'll probably still have a great time. What we can also look at is all the other options in here. So chromatic aberration, again, setting it to 0, no visual effect. It's great for us. Other things to look out for, lens flares, that's another one. Motion blur is a big one, because to blur something means it has to affect it over time. So we can also remove motion blur, and obviously just keep doing kind of these adjustments. Again, coming in deciding, do we really need screen space ambient occlusion? So something to realize is as we use ambient occlusion, in the post-process volume, when we see ambient occlusion here, this is a screen space effect. So what does that mean? It means that it's using, in deferred, it's using the scene depth, which is, we can actually look at it right here, scene depth. So it's realizing the depth of the scene, it's realizing objects next to each other, and it's building out these little occluded shadows, aka pinches, because as light beams try to bounce, they can't quite get in, and so you get darkening and crevices. So this effect is looking at the screen buffer of the depth and saying, okay, where are those little occluded areas and where can't light get in, and then add it over. So we have to pay, again, another screen cost for this. Setting it to 0, this might still be an acceptable answer, and our game's going to run a whole lot faster. So don't be afraid if you're not getting the performance to come here and take some of these things out. Now, what we can do, because this is a screen space effect, and if anybody says that, it just really means it has to do math on the pixels. You don't get it kind of cached ahead of time, aka saved ahead of time. Now, what you could do is come into your world settings, come down to your lightmass settings, and you could enable, let's do AO, ambient occlusion. Use ambient occlusion. We could use this. We could set our settings. So that is under lightmass. Sometimes I forget exactly where it is. Right here. We could set this, and we could bake it out. We can even change how much AO is applied in the direct light and in shadow, and kind of tune that without having to pay that screen space effect cost. Now what I'm going to do, again, we have a warning here. Warnings are never good. Basically, it's saying that those reflection probes that we updated their position need to be rebuilt, aka we moved them around, and so they need to take a new picture, and they need to project out what they're doing to the meshes around them. And then lights need to be rebuilt. If we tried to push this, a lot of these lights would default, because they're stationary, to movable lights. You pay a huge cost. It's very bad. So whenever you see lights need to be rebuilt, we'll just come up, we'll click build. It should only take a couple seconds. It just kind of depends on your PC. And we shouldn't notice that much of a difference. Now, that might be crazy to you and say like, well, I need more performance or I need less performance. And what you start to do is you start cutting more corners. And again, it really comes down to how much time do you have to do math on pixels. And I could tell you that the next thing I would do in terms of performance in here, it would be anything transparent. So this, this fog. So if you need to select a fog actor and you can't select it, see at first I couldn't select it, hit the T key for transparent meshes. What I would do is I would probably get rid of at least one, if not two of these. Again, transparencies, you have to pay a cost to render through them. So I might take some of these out just for a more efficient build. Again, it feels pretty good. We still have some motion in the scene. That's usually pretty important. I think the fog, we still have one plane over here, which feels nice. We might even be able to optimize this down to 1, kind of have doing this. But this kind of panning thing still feels good. Our scene looks relatively the same. We haven't really lost any quality. And you'll notice if we had that movable object, I think it was called a Dyson. That doesn't have a texture on it, but that's fine. It'll still do. You'll notice that this object still has all of its lighting. And in closing, we'll just roughly talk about the volumetric lighting samples. And so what are those? So if we come into show and advanced, and we go actually visualized, and we go to volumetric light map, what you'll see are these little spheres. And you might ask yourself, well, what are those little spheres? And what they are is information cached in a point. So this is what the light intensity, color, and direction, overall direction was at this specific point in the level based on the baked lighting. And so as we move this guy around, he will query and ask these different points. They will kind of average between them, and he will get his ambient light. So you can notice that these aren't casting any kind of shadow for him or anything like that, but he's getting his ambient term. You'll notice he gets over here, gets a little darker, and these spheres are a little darker. You bring him back this way, he gets a little lighter. And that's really where he's getting his kind of general lighting from. And it looks pretty good nowadays. I would even suggest if you needed to get it even faster, most of these stationary lights in this example could be set to static. And because of the indirect lighting cache will still be here, your object will look pretty darn good. Really what we're seeing right here is a screen space reflection. Again, that's in the post-process stack. It costs time. So if you don't have the time, you should take it off as well. And what you'll notice is that wherever your light mass importance volume is, again, light mass importance volume being a volume, right here you'll see this orange box. Anything within that box gets better baked lighting calculations, and also you'll notice that the density of these samples is higher in here because obviously it thinks that that's where characters and other movable objects will be. And then it just does a real general kind of approach to way less samples of information outside of that. And that is to make sure that, let's say you had a background with like a mountain or something on it, that it could still have some lighting sample information. So at this point now, we've talked a little bit about the lights, how to optimize them and when we would optimize them or change them. We talked about reflection probes and the cost of overlapping them, putting only one or two in some detailed areas and having kind of a general one to take up a bigger area so there's less cost there. We talked about the post-process stack and how each one of those effects will make extra math and calculations on all of the pixels. And then we talked about the indirect lighting cache and how it can be very useful for us in terms of being enough lighting in most cases for our movable objects to get around. So again, I hope this helps you guys understand a little bit more about optimizing your lights and your scenes inside of Unreal. Thanks.